In this video, we will study how to convert binary numbers to decimal numbers. It is really easy, just like the previous examples we have done for converting from decimal to hexadecimal and then converting back from hexadecimal to decimal numbers. And then we did example for decimal to binary conversion. Now the time is to how to convert from binary numbers to decimal numbers. So let's do one number conversion from this table actually, so we can see our answer if it is correct or not. So let's choose any number. We will do two examples for this table. So let's choose this 7. Let's convert this 0 triple 1 0 triple 1 to decimal number. So the method is really easy. 0 1 1 1. This is equal to, we have to multiply each digit with the number 2. If we were converting it to hexadecimal, then we would multiply with 16. We already saw that in previous videos. Now we are converting from binary to decimal, so we will be multiplying each digit with 2. So 2 times 0 for the first one plus 2 times 1 for the second one, this one, right? Then we have these digits which are 1. So 2 times 1 for this one, and then for the last one, 2 times 1. Okay. I add these dashes at the bottom just so we can distinguish that we are doing this multiplication for 4 digits. Okay. So after this, the important step is to add powers to these 2 digits. Like the number 2, we have to add powers. So starting from right, remember this. You should always start from the right hand side to add these powers. So that will be 0, 1, 2, 3. So now we have to simply do this simplification. So 2 power 3 is actually 8, but it is multiplied with 0. So this will be 0 plus 2 times 2 power 2 is 4. 4 times 1 is 4 plus 2 power 1 is 2 and then multiply with 1. So we get 2. Anything with power 0 is always 1. So this becomes 1 times 1. So if we add all these numbers, this becomes 4 plus 2 is equal to 6. 6 plus 1 is equal to 7. So we can see that 0 triple 1 is actually 7. Okay, let's do another example. Let's do it for 13. Okay, so now I want to convert 1101 to 13. So the first step is multiply each digit with 2. So 2 times 1 plus, let me add brackets to distinguish between each multiplication. Then for the second digit, 2 times 1, right? Plus, then for the third one, 2 times 0. Then for the last digit, which is 2 times 1. You can see when I do this multiplication, I start from the left-hand side, right? First I multiply with this digit, then this, and then so on till the right-hand side. But when I write these powers, which I will be writing now, that must be always started from the right-hand side. So 2 power 0, 2 power 1, 2 power 2, 2 power 3. So this becomes 2 power 3 is 8. We know that, like 2 times 2, 4, then multiply by 2 again. So it becomes 8. So 8 times 1. Okay. Plus 2 square, this is 4. So 4 times 1. Now 2 power 1 is 2, but it is multiplied with 0. So I will directly write 0. Okay. And anything with power 0 is 1. So this becomes 2 power 0 becomes 1. So 1 times 1. So this becomes 8 plus 4 plus 0 plus 1. So 8 plus 4 is 12. 12 plus 0 is 12. 12 plus 1 is 13. So we can see we got this result for 13, which is seen over here in this table. Now let's do this for like 8-bit binary number and do another example. So let's go to the next slide. Now let's do an example for a 8-bit binary number, which will have 8 digits written in binary. So let's choose a random number. let's choose 1101. Okay, 0010. Okay, so we can see 4 and 4. So we have these 8-bit number written in binary. So now I want to convert this to decimal number. So this is really easy. What I have to do is that I have to start from left hand side and multiply each digit with 2. So this becomes 2 times 1 for the first one plus 2 times 1 for the second one, this one, okay? Then this is 0, so plus 2 times 0. You can even directly write 0 over here if you don't want to go into this, but that will confuse you when you are adding the powers. So it is much better to write this in the first step, and in the second step and the following steps, you can directly write 0. So now the fourth one, this becomes 2 times 1. Now plus this 2 times 0 plus again 2 times 0. Then we have 2 times 1 for this digit, and then plus 2 times 0. The reason I told you that you should not write directly 0 over here is that when you add powers here, you will get confused because the power should be incremented by 1. So you can see here 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so now we know that 2 power 7 is 128. Please confirm this in your calculators. So I may have made a mistake, but this is 128 plus 2 power 6 is 64. 64 times 1. Now in this step, I don't need to calculate 2 power 5 because I already know the result will be 0. So I will simply write 0 over here. Now 2 power 4, this is 16. 2, 4, 8, 16. Yes, 16 times 1. Okay. Plus this will be 0. Again, this will be 0 plus 2 times 1, and the last one will be 0 again. Okay, so this becomes 128 plus 64 plus 16 plus 2. So when we add all these numbers, we will get our result. So starting from, let me use calculator. So 128 plus 64 plus 16 plus 2, this becomes 210. So this answer is in decimal number. So 11010010 in binary is equal to 210 in decimal. This is our result. So this is conversion from binary to decimal. Okay, let's do one more example to see. In the last digit, I will not choose this as 0. So we can have an odd number. We will see if we will have an odd number. So let's do another example. Now I will choose a number in which the last digit is 1. So let's do another example. Let's say we have 1100. Okay, this is the first one, 1001. We have this number in binary. By the way, just to give you an overview or like a review of the conversion from hexadecimal to binary. So if we had this number in hexadecimal, which is C, represents this one, right? 1100, and then we have 1001, which is 9. So we can directly see 9 if we were asked to convert hexadecimal to decimal. So what we can do is we can convert hexadecimal to binary as well. So that will become 11001001, and then convert it to decimal. Okay, or we can simply write, we have already done this, c uh, sorry c9 equal to 16 times c plus 16 times 9, then add powers to it. So this becomes 16 times. Now c represents 12. Okay, this is just review how to convert from hexadecimal to decimal. So 16 power 0 is 1 times 9, so we get our result over here. So here, the main part of this, the main agenda of this video is to convert from binary to decimal. So let's do that. So starting from the left-hand side, 2 times 1, right, for the first one, plus 2 times 1, plus. Now I don't want to write 0 directly over here because when I add powers to this number 2, so that will get confusing. So in the first step, we should always write it like this: 2 times 0 for the third, plus 2 times 0, then plus 2 times 1. This was for this one. And then again plus 2 times 0 plus 2 times 0 for the next two digits, and then plus 2 times 1. Okay. Now I have to add powers. So starting from right hand side, remember this: 0, 1, 2, 3, 4, 5, 6, and 7. So 2 power 7 is 128 times 1, plus 2 power 6 is 64. So 64 times 1. Now I can write 0 because I just have to simplify it. So 0 plus 0 again, plus 2 power 3 is 8 times 1. Okay, plus 0 plus 0 plus, and for this 2 power 0 is 1, so 1 times 1. Okay, so this becomes 128 plus 64 plus 8 plus 1. So 128 plus 64, this is 130 plus 62. So this becomes 192 plus 8 plus 1. So this becomes 201. Please confirm this answer. So let's see if we can get this answer from here as well for the hexadecimal to decimal. We will find out if I made any mistake. So 16 times 12 is actually 192. If we do this multiplication, if I'm doing it correctly in my mind, this should be 192, then plus 9. So this becomes 201. So yes, if we follow this conversion from C9 to binary number and then convert it to decimal, so we are getting same answer in both cases. Anyways, the main agenda of this video is to convert this binary number, the decimal number, which is 201. So we got our answer. If you have any question, then let me know. I will answer that. Thank you.